Hey, we have Luke Sully Walker here, and we're going to fight the dark side. You know, all these problems in geometry, they actually call it space geometry. They happen in space. So we need some space fighters for us. So we have Sully Skywalker here is going to help us through these different problems. We're learning about polygon angles, and specifically, we're going to start by looking at the number of degrees in all of the angles if you add them up on the inside. In other words, like how many degrees are in the interior angles of a triangle. We already know this. All right, so we know if we add this angle to this angle to this angle, the total number of degrees in the triangle should be 180. So that's what this last column is here. We're going to start filling in the table and looking at this because the question is, well, what about for a quadrilateral? How many total degrees are in a quadrilateral? How many total degrees are in a pentagon? That's where we're going with this. Okay, there's a column here that says the number of triangles. For right now, we're just going to put a 1 there, and this will make more sense in a second. All right, so we had one triangle, and the sum of the interior angles are 180 degrees. We know that about triangles. Let's try a quadrilateral. All right, so what I'm going to do is I'm going to divide the quadrilateral up. Pick a vertex. It doesn't matter which one, but I'll pick this one down here. And then what you do is you connect all the vertices. Now some of them, the two edges here, they're already connected, so I don't have to draw those. But any that are in the middle like this, that should be a straight line. But basically what I've done, you think Mr. Kelly could actually make a straight line here? God, he has technology. Why don't you do that? There you go. So there's a straight line. So how many different triangles did I create? Well, we created 1, 2 triangles. Well, if I add it up, all right, the degrees in all of these plus the degrees in all of these, basically you've got the degrees in the whole quadrilateral. So if I add up the degrees in both triangles, well, that's easy. That's 2 times 180. 2 times 180 degrees. Okay, that equals 360 degrees. So for a quadrilateral, it's 2 times 180 because we can draw 2 triangles. Let's try for a pentagon. Pentagon has 5 sides. So as I said, you pick a random vertex. All right, I'll pick this one over here. Draw to the other vertices. So not that one because there's an edge there, but we'll go to that one. We'll go to this one. So how many total triangles can we draw if we have a pentagon? Well, we have 1, 2, 3. All right, so we can draw 3. So this is going to be 3 times 180. That'll tell us the total number of degrees in a pentagon. Well, 3 times 180 is 540 degrees. Let's go to the next one, last one. All right, you do the last one by yourself. Go, please, you did it by yourself. Look, I drew from this vertex, and I hope you used a different vertex just to show that it works, I mean, from any vertex, really. But what you have to do is draw your different diagonals. These are called diagonals. And you can see that this makes 4 different triangles, and so it would be 4 times 180 would be the total sum of all the interior angles of a hexagon. That has 6 sides. Now, the question then becomes, so what if you just give me the number of sides? Can you then just compute it without having to draw these triangles? Because sometimes they give you figures which are called n-gons. Ooh, n-gon. That just sounds like Star Wars right there. So if they give you a 21-gon, what that means is you have a polygon with 21 sides. If they give you a 42-gon, all right, so that means a polygon with 42 sides. That's a huge polygon, but they might do that. Sometimes they call it like 13 gons and 9 gon they might call it instead of a nonagon. So anyways, the question is, if you get a certain number of sides, how can you figure out how many degrees are on the inside if you add all of the interior angles? Well, if you notice, let's look for a pattern here. 3 goes to 1, and 4 goes to 2, and 5 goes to 3, and 6 goes to 4. All right, so this number here is 2 less than whatever the number of sides is. So we're going to write that as n minus 2. All right, that's just 2 less. So you tell me the number of sides, and you subtract 2 from it, and that'll tell you how many triangles. And then it's each triangle times 180 degrees. So this is n minus 2, we're going to put that in parentheses, times 180 degrees. And that'll tell you the total sum of all the interior angles. So here we go, polygon angle sum theorem. The sum of the measures of the interior angles of a polygon is n minus 2 times 180. And I'm using extra parentheses than you might see in the textbook or online somewhere if you're looking at someone. That's okay. Remember, it's okay to have extra parentheses. Sometimes it's not okay not to have enough parentheses. Yoda, lead us the way. N is the number of sides in the polygon. Subtract 2 from it and multiply by 180, and that'll tell you how many degrees are on the inside of the polygon. So we're going to look at these 2 examples here. You first have to count the number of sides. So in this example, this is a pentagon. There are 5 sides. All right, and in this example, there are 4 sides. This is called a quadrilateral. Okay, so in the pentagon, all right, 5 sides, so the total number of sides is, or the total number of degrees, and the interior is 5 minus 2 times 180. Now if you want to, you can draw the triangles, but you don't have to do that because we have the formula now. That's just going to be 3 times 180, okay, which equals 540 degrees. All right, so how do we solve this problem now? Well, we're going to create an equation. All of these angles here, whoopsie, all these angles, if you take that angle and this angle and this angle, they should add up to 540 degrees, and we know that because of our formula that we created. So we're going to actually write out here, let's write an equation. We have x plus 125 plus 97 plus 107, oop, forgot my one, plus 83, that should all equal 540 degrees. Well, now it's just a matter of combining like terms, right? We just got to combine like terms. I got some writing down here I got to get rid of. Alright, so basically add all these numbers together. So x plus, what does all that add up to? Someone tells me 412? There's a voice inside my head. Use the force. Alright, and then so what do we get? We get, let's see, 540 minus 4, and that's 100 and what, 28? Alright, so x equals 128. So that's what we get here, and we can check it by adding them all up, and it should equal 540 degrees. Alright, let's try the next one. This is 4 sides. So how many degrees are in a 4-sided figure? You can go back to the chart if you want, but it's smarter to figure out where this all comes from if you can calculate it. There are 4 sides, so it's 4 minus 2 times 180, or basically that's 2 times 180, which is 360. Alright, so there are 360 total degrees. Let me change up the color here. So if I add all of these up, you should get 360 degrees. So 2x plus x plus x plus another 2x should equal 360 degrees. Fit? Alright, so 2, 3, 4, 5, 6. We have 6x equals 360 degrees, or we get x equals 60 here. Now be careful because they might ask you what are the angle measures, in which case you'd have to say 60, 60, and 2 times 60, or 120. Make sure you're double checking what the question asks, because sometimes they don't want what x is, they want what the angle measures are, so you have to plug it back in. So now we're going to talk about regular polygons. Regular polygons are polygons that have equal, they're basically all the sides are congruent, all the angles are congruent. They're the pentagons that look like pentagons, the octagon that looks like an octagon. When you look at it, all the sides are the same, and everything is nice and symmetric. Because each polygon with n sides, alright, that's a little confusing, has also n angles, you can divide the sum of the angles by n to find the measure of one angle. Alright, so let's come up with it. Let me tell you the theorem. Let's do the theorem and then I'll do an example. Alright, so it's, what do we have? N minus 2 times 180. That'll tell you how many total degrees are on the inside. Let's look at an example here. Let's pull out a hexagon. Alright, so if we have a hexagon, what are we looking at here? What's the total number of degrees in the interior angles? That's what this formula is. Okay, so the question is, what if I want to know just one angle? Well, this only works for regular polygons, because regular polygons, they're all the same. If they're not a regular polygon, they could all be different, so you can't really answer this question. So for a regular polygon, you can take the total number, which in this case would be 6 minus 2 times 180, but then there are 6 angles, so then you divide it by n. Okay, whatever that is. So this is the formula for finding one of the angles if all the angles are the same. So do you have to remember this formula? Not really, because you could go back to the other formula, just find them all, and then count the number of angles and divide it. That's pretty easy to do. What about, oh my goodness, it says something. That is, don't worry, we'll get you out of this mess. We'll get you out of this mess. What about exterior angles? Okay, so if we want to know how many degrees are in the exterior angle here of, well, what is this? First I'm going to count this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a nonagon, or it's a 9gon. You can think of it either way. So how many degrees are in the external angle? Alright, well, one way you could do it is n minus 2 times 180. Alright, well, let's do it this way. So what does that give us? So if this is a 9gon, we get 9 minus 2 times 180, which is 7 times 180. Oh my God, I'm going to have to get my calculator out. Even Mr. Kelly can't do that one. 7 times 180 gives us 1260. All right, so this all equals 1260. So what I just said before, remember finding one angle? This one has 9 angles. So if I take this and divide it by 9, I get 140. So there must be 140 degrees in each one of these angles. 140, 140, 140, all the way around. So if there are 140 degrees in this angle right here, look, an exterior angle is created when you extend an edge, and it keeps going like it's an array. It goes outside of the polygon. All right, so because you extend that, you have an angle here and an angle here, which form a linear pair. Well, linear pairs are supplementary. They add up to 180. So if you take 180 and you subtract 140, all right, 180 divided by, let's see. Oh, we're going to subtract. Don't divide. You're going to confuse kids. No division. We're going to subtract 140. You get 40. So the total number of degrees in an exterior angle here is 40. All right, that's a long way to do it. I'm going to show you a short way to do it, and we're going to use our Jedi forces here. We're going to save Princess Sully. But let me recap what we just did there. We found the total number of degrees in the whole nonagon, and then we divided by 9, and that found one angle. The exterior angle you subtract from 180 because they are linear. They form a linear pair. They're supplementary. Let me show you a different way. I'm going to use the formula. I'm not going to use the force. We're going to use the formula. Here we go. All right, so what are we going to do here? Let me just recap what we're going to do. Remember that whole process we went through just 1 second ago? We took one interior angle, which we found with this formula, n minus 2 times 180, and then we had to divide that by n to find one angle. We subtracted all that from 180 degrees. Okay, so that's how we found an exterior angle. I'm going to use the formula to save Princess Sully. Now, this is going to get ugly. Might be some blood and guts of the numbers. So if you get scared of like formula derivation, then close your eyes for 1 minute. Ready, set, go. Here's what I'm going to do. I'm going to simplify this. We're going to distribute the 180. So, not the first 180, but the second one. That's going to go to both terms. So we get 180n minus 360 all over n. And remember, that's like one thing in itself. All right, now what? All right, now I'm going to break this up using the distributive property. Instead of being 180n over n and 360 over n, it's going to be, I'm going to try to do this fast because I know some of you are going to be like gouging your eyes out. 360 over n. All I did was take that. Remember, Bruss taught us this in section 2.4 in algebra. It's like the distributive property. Now what? Well, look, this is awesome. After I break this fraction up with the same denominator, these n's cancel. And now I can distribute this negative to both. So what do I get? 180 minus 180. The n went away. And then a negative times a negative is plus 360 over n. Oh my goodness, look, 180, they cancel. Basically, you get 360 over n. That's what it reduces to. Let's try that. Let's go back here. This is a nonagon, so if I take 360 and I divide it by 9, what do I get? Voila! 40. How quick is that? That is quick! We have a new theorem now. The sum of the measures of the exterior angles in any polygon is 360 degrees. In other words, if you add up all of the exterior angles, they add up to 360 degrees in any polygon. Pentagon, hexagon, heptagon, octagon, nonagon, dodecagon, whatever you want to get. Okay? Some of you wish Mr. Kelly was gone. Let's try some examples. Find the measure of one interior angle. Why don't you do these examples? Pause the video, do 1, 2, 3, and 4. Go! All right, so let's look at numbers 1, 2, 3, and 4. Hopefully pause the video and you figured these out. Now, the quick way, you could just use this formula right here. Remember, n minus 2 times 180 all over n, which is essentially what I did, but I did it the other way because I think this way you can understand a little bit better. All right, so this has, what is this, a heptagon. It has 7 sides. So you plug it in, n minus 2 times 180. 7 minus 2 is 5. You get 900. And we're asking to find the measure of one interior angle. So all of the angles, when you add them, will equal 900. You have to divide by 7. That'll find one angle. You get 128.6. You have to round it to the nearest tenth if asked. How about a 15 gon? Remember, that has 15 sides. Plug it in. So it's 13 times 180, you get 2340, you divide it by 15, you get 156. Or you could just plug it in that formula right there, it gives you the answer all in one step. Let's look at the next section. Find the measure of one exterior angle. Remember, an exterior angle is if you extend an edge and you keep going there. So what do we have? 360. Let's see. They all add up to 360. If I extended all these sides out, extend them, extend them, extend them, extend them, extend them, they would all equal 360. So if you divide by the number of angles, it'll tell you how many degrees are in one exterior angle. So for an octagon has 8 sides, 360 divided by 8, you get 45. And for a 13gon, yeah, you divide by 13. That has a name. I don't know what it is. I forgot what the name is. Some triceratops or something. Anyways, you get 27.7 degrees. You have to round it to the nearest tenth. All right, try 5 and 6 right now. You got to put your thinking caps on. Go. Okay, so I did the first two. The last one's kind of tricky, so I'm going to help you out with it. But the first two, a decagon, you have to know what that is. It has 10 sides. And so you plug a 10 in, you get 8 times 180, which is 1440, and you're done. They're not asking for one angle, they're asking for the sum of them all, so you're all done right there. For number 6, you get a pentagon, so you get 540 degrees. Voila, you're done. Now, this last one looks like it's kind of tricky. I mean, what can we do here? Well, the only thing you know is that the exterior angles add up to 360 degrees. We just did that. All of these exterior angles add up to 360 degrees. So if I didn't know that, I'd probably be stuck without some higher math. But looking at this, if I add all the exterior angles, so if I add z plus z minus 13 plus z plus 10, okay, you ever cross your z's? That way they don't look like 2's. They should all add up to 360 degrees. That makes this problem a little more easy, not difficult. So you got 1z, 2z, 3z, minus 3, we're combining like terms, equals 360 degrees. Okay, add 3 to each side. We get 3z equals 363. If you take 363 and you divide it by 3, you get 121. So that's what z equals. So now, all right, so if z equals 121, we can start figuring things out. So these two are supplementary. So 180 minus 121. What do we get for there? 180 minus 121, okay, is 59 degrees. So that's x. 121 minus 13, so you subtract 10, you get 111. Subtract 3 more, you get 108. All right, so this side is 108. 108 has to be supplementary. These two add up to 180, so we get 72. All right, and what do we get here? So this would be 131. So this would have to be what, 49? Let's do a double check to make sure all these add up to 180. So if we take 59 and 49 and 72, that's 18. That'll give us 20. All right, 7 and another 7 is 14, 180. We're all done. Okay, so that works. All right, we figured it out. I mean, these hard ones here, you just got to go through and start chipping away. You find one thing, then you can find something else out. Look for supplementary angles, linear pairs, and all that kind of stuff. So, all done with that one. This isn't too bad. Hopefully everything went okay, so you can take a master check. Remember, it's Mr. Kelly from Bomb Holders. Nice to be important. It's more important to be nice.